This conference will now be recorded.
All right, so let's start with some basic rules. Okay. Whenever you are creating a class, make sure you give some specific names. Okay, do not name your programs like ABCD or something like that. Okay, if you're writing a program for school, call it school. Okay, if you're writing a program for bicycle, you need to write bicycle. Okay, so make your name your program properly. Okay, that's the rule number one. Okay, now there is a certain coding standards that we follow on how the name should be written. Okay, now if you have more than one word, okay, so you have to write something like this. You have to capitalize the first character of the first word. Supermarket. Okay, if it is two words, the first character of the first word should be capitalized, and the first character of the second word should be capitalized. Okay, this is a naming convention you should use. Now, during the course of your time, you'll come across so many concepts. Okay, you'll learn what a class is, what a variable is, what a method is, interface, abstract class, so many things. Finally, okay, every concept has its own meaning. So following a certain guideline helps you to understand what you're looking at. Okay, by looking at the naming convention, you can tell if you're looking at a class or an attribute or at a method. Okay, always start the first character of each word as an uppercase, capitalized, when you're naming a class. Okay, if you want to name bank account, how do you write that?
B as capital.
B as capital, then
A as capital.
the next letter is lowercase or uppercase?
Lowercase.
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 And
then
uppercase.
next word, account. Okay, this is how you name your programs. Okay, so you will come to know when you learn all the stuffs, all the feature, all the OOPS concept, you'll understand the need of this naming coding standard. Now here is the thing, if you do not follow this naming convention, your program will not fail. Okay, you can name whatever program name you want. Okay, that is not a rule that you should write it like that. But as a general coding guideline, it is suggested or encouraged that you write a proper name like this. Okay, that's the first one. Now, like I told you, every program has two parts, variables and methods. Okay, attributes and activities. So you have attributes that are bound to change. Okay, and you have activities that work upon the attribute. So let me tell you, let me give the example I gave you yesterday. You have bank account. Bank account has money and name, account number. Okay, and you have withdraw, you have deposit. Okay, so these are what we call variables and methods, attributes and activities. Okay, so let's take the first part. A more technical word is variable. Okay,
I have a question. Bank account is a class?
Bank account is a class, yes.
Okay. Okay.
Okay, so we are writing a program or software for bank account, which has these things and which does these things. Okay, So to begin with, you start by creating the class first. All right, so don't use the main method in this. Main method was only for the first chapter when you want to get the output. When you want to run the program, you need the main method. Okay, you do not need the main method in all the program. Remember that. Okay. So this is the syntax of a class. Okay, it starts with keyword, public, class, and class name. Okay, so when you want to write a program for bank account, you start with the proper naming convention. Okay, and it goes like this: public, class. Class is the keyword to signify that this particular name that you see, right? It is a program. It is a class program. Okay. Now this is what we call the class body. Okay, this is like, think about the boundary. Okay, you're marking your boundary on where the program begins and where it ends. Okay, this is the boundary of your program. Anything you need inside this program, okay, should be written inside this boundary, a curly bracket. Okay, it looks like this. Okay, we call it as a curly bracket. So this is what we call a opening curly bracket, and this is a closing curly bracket. Open and close. Okay, so this is what defines the boundary of your program. So whatever you want inside the bank account software should be written inside these curly brackets. Okay, whatever you need inside the bank account software, it should be written inside this curly bracket. All the attributes, all the activities, all the variables, and all the methods, they all should be written inside this opening and closing curly bracket. So we call this as a class body. Okay, this is the body of your class. Is everyone with me?
Yes.
Yes.
So as you see, once we go forward, you'll understand what this public means and what are the other options you have. Okay, but right now just remember every class has that public class and all that. Okay, you have several other options too. Okay, but for now just remember that this is how you create a program: public class followed by the class name. Okay, this defines the body of your program, the boundary of your program. Anything you want to write as part of this program, this software, goes inside this bracket. Okay, all right, so let's see what an attribute is. Now when you hear the term variable, what comes to your mind? What do you mean by vary?
Changing.
It can be
Vary.
changed.
It keeps
It
changing.
changes.
Change.
It's
It's not
changing.
static, dynamic.
Variable is actually derived from this thing: varies, vary. Okay, varies, vary meaning it is actually telling you that this particular attribute is bound to change. Okay, now changeable. Money can be changed, name can be changed, the account number can be changed. Okay, now tell me one thing: who is responsible for changing these things?
Customer.
Customer.
In this class.
Bank account.
Okay, look at this program and tell me, when will the money change?
Methods.
Yeah, method. Yeah, withdraw deposit.
When you withdraw or deposit.
Okay, methods are actually operating on variables. The state. Okay, so you might hear this term quite often: state. The state of the class is changed by the method. Variables maintain state. Okay, so state. Now, when you hear the term state, think about water. What are the different states of water? Water
Ice,
can be,
ice,
Solid, liquid, and
vapor,
gas.
can be
Liquid,
liquid,
Solid,
solid,
vapor, or gas.
okay,
Yeah.
gaseous state. So do you when they say state, okay, from our school days, we remember this as a chemical term, right? It's solid,
Yeah.
liquid, gaseous. Okay, so you might often come across whenever you're going through some object-oriented tutorials or something, right? You might always come across state. The state of the program changed. The state of the class changed. The state of the object changed. So what they are basically telling you is the variables that you had in your program that changed. Now, when I say withdraw, it is going to change the state of the money variable, isn't it?
Yes.
State as in, if the current value was 100, if I had $100 in my money attribute, when someone says withdraw 50, this method is responsible for changing the state of money from 100 to 50. Okay, that's what change in the state means. Change in the state is basically referring to the value that your variable holds. Okay, state. Changing state meaning changing information. Okay. And now variables are very, very important things. It is actually the core of your entire technology. Okay. Now, basically all the internet applications and computer applications says IT, right? What does IT stand for?
Information technology.
Information technology.
Information technology. So what is this, all this thing?
Information.
Is attribute an information or an method is an information?
The
Money is.
attribute.
This is what we call information, right? The money in this account, that is an information. The name on the account, information. The account number on the account, information. So the entire IT, you see the basis of IT is how you store information and how you manage information. Okay, storing information. Use Facebook. It stores your information, your name, your educational background. Okay, what are the messages you posted? What are the pictures you posted? Aren't they all information?
Yes.
Now, what does the activity do? It manages that information, isn't it?
Yes.
Yes, sir.
Okay. So IT, anything, you take any example you can think of, Google, Facebook, Amazon, all they deal with is information. Okay, there are two kind of things you can do with that. You can either store that information or you can manage or manipulate, okay, or update, whatever you call information. So IT is all about storing information and managing that information. You change that, you delete that, you add new information. That's all there is. The entire IT is based on these two techniques, storing and managing information. So look at the Java program. What does variable or attribute do as part of the IT concept? Does it do storing or managing?
Manage.
No, it's storing, I think.
It stores the
Or
information.
manipulates, yeah.
Managing is the person who manipulates the data. Okay, when I say I manage your money, what do I do really? Okay, I invest in that, I grow it, or I take a huge loss. Am I not working on your investment? When I say there is a financial manager, right? Investment manager, you give me your money, that is your information. What do I do with that? I manage it by investing it somewhere, by taking a loss, by taking a profit. So the person who changes that information is what we call manage. Storing information. See, money on its own, does it change? Now, if I give you a dollar, does the dollar on its own change by any chance? Or
No.
if I give, if there was a note, $1 note printed, will the value of that note always remain the same? or is it supposed to do something on its own?
Remain same.
Remain same. We are the person who exchange that note hand to hand. We take it, we spend it, the other person spends it somewhere else. It keeps on moving around. So who is managing that? We all are managing that. So think about that. Variables are meant to only store information. On its own, it doesn't do anything. It will just store information. That's all. Today I'm storing 100. When you withdraw, I will store another number, 50. But the person who is changing that information or managing or updating is the method. Okay, remember, this is the state of your object. Okay, now when I say, what do you have in your bank account? Do you say I have withdraw in my bank account or deposit, or I have $100 in my bank account? What do you think?
I have 100.
Right? So when you refer to a state of a program, okay, tell me what is the state of your bank account. You don't say I have withdraw. That's not the state. The state of bank account is, okay, the state of my bank account is I have a checking account. Okay, I have $100 in it. That's what the state means. State is always referring to variables. Okay, whatever current information these variables hold, that represents the state of the bank account. The state of the bank account is it has $100. It has been assigned to John Doe, and the account number is 1234. This is the state of your bank account. This is not the state. You can't even phrase that in a question. And that applies to everything. If you have product has name, quantity, price, and then it has activity buy or sell. When you ask something about if you want information about a product, what do they tell you?
Name.
Name.
Name, price.
Okay, yeah. So you look at some product you're browsing through in a store, you look at something that you like, and when you ask someone, tell me about this product, tell me the state, tell me the information about this product, they tell you these things. They tell you what is the name. It's from a Samsung brand, very popular, very trustworthy. Okay, we have 10 quantity. Okay, and the price, this one goes for $1,000 a piece. That's what information is. Nobody really deals with activities. Okay, so remember what a state represents. State represents a variable. Okay, the attributes of the software. Okay, all right, is that clear? IT is all about information, storing information and manipulating information. Okay, changing. You add some information in your Facebook account, you delete some information, you update an existing information. You're always constantly changing that, playing with that. So IT is all about storing and managing information. If you look at a program, the Java program, that's what it gives you. It allows you to store information, and these things allows you to manipulate these information. So is that clear on why do we really need these two categories in a program?
Mm-hmm.
Does that make sense?
Yes.
Yes, a lot.
Yes.
All right, so let's go through the process. Okay, so now that you understand why we need variables and method and what role it plays in a software world, okay, let's look at what are the ground rules, what are the technical syntax that you need to follow. Okay, data type. Okay, every variable has to be written like this. Okay, so let's take the same example, bank account. You have money, name, account number. All right, so we are dealing with variables. Now, there are three parts here. Okay. The first part is what we call data type. Okay, data type. So when you hear the term type, you basically think about categories, right? What type, what category it belongs to. Okay, what category this information belongs to. Okay, now no matter how complex your software is, when it comes down to the information storage technique, you will finally narrow down to few options. The information could be a character. This is an information you want to store. What else can you store?
Alpha number.
Numbers. A fraction number.
Numbers and integers together.
True or false?
True or false, that's the final thing. Okay, when it comes down to the simple aspect of data storage technique, this is what it finally narrows down to. Okay, you have either an option to store characters, or you have an option to store a whole number, or a fraction number, or just a basic simple yes or no, true or false. Okay, the entire programming language, entire information systems that you see, right, like Facebook, Amazon, they have petabyte of data, petabyte. Okay, thousands of terabytes of data. Okay, about you, about your friend, about your family. Okay, all that information that you see out there, when you really think about it, it finally narrows down to a simple category, such as the information could be a alphabet or a number, or it could be a fraction number, or it could be a simple yes or no kind of information. Gender, yes or no. Okay, are you alive? Yes or no. Is the shop open? Yes or no. So if you really think about it, in the end, it always comes down to true or false kind of a category. Okay, yes no kind of situation. Okay, so this is what you can think as a building block of the entire system. If Facebook information about all the billion user is like a huge skyscraper building, then these information would be the brick in that huge building. These are the building blocks. Okay, every information, if you really think about it, it will finally narrow down into these categories. Okay, so let's go back. Account number. Now, what kind of category does it fit into in these?
1 0.
1 0, yeah.
The numbers, right? And that's what this type indicates. Okay, so a variable has two parts. One is what is the type of information this attribute can hold, and what do I call it? Okay, what is the information it can hold, and what do I call it? The information it can hold is a number, and I'm going to call it account number. The information that it holds is a fraction number. For fraction number, we write float, and I'm going to name it money. Alphabet, a group of alphabet, John, John, 4 characters, right? So a group of character is represented as string. Okay, so every time you're declaring the first part, okay, every time you're declaring the first part, the variables, the attributes, you have to write it like this. First, you need to decide what kind of information it can hold. Okay, name is a bunch of characters, so we'll write string. Quantity is a whole number, we will write int. Price is a fraction number, we'll write float. Okay, so this is the kind of information it can hold. Now, these are the building blocks. Okay. Now there are certain options you have when you come to a number or a fraction number. Let's see what they are. You can declare this as byte, short, integer, or long. Okay. Now there are 4 categories, 4 types available to store a number. All of these will allow you to store a number. 1. Okay, all of these allows you to store number. Now, if you recall, byte, what does 1 byte mean?
8 bits.
8 bits, right? So 8 bits. Now I already showed you in your first class what is the maximum data you can store in 1 byte, right? These are the numbers you can store. I already showed you how the numbers are stored in 1 byte memory, like this, 101010, right? Now here, a byte has a certain limit. If you add up all these numbers, you get about 128. Okay, if you add up all these numbers, you get 128. What I mean is, +64 +32 +16 +8 +4 +2 +1. If you add all those numbers, you get about 128. So in 1 byte, you can store only about 128. Okay, the first bit is usually used to signify a negative or positive number. Okay, so that's why we ignore the first bit. Okay, so your remaining 7-bit allows you only a combination of up to 128. Okay, so if I store the number 130, you get an error. If I store 5, it is fine. Okay, now every time you choose a data type, some memory is allocated in here. Okay, we allocate some memory in the RAM, and you already know how precious RAM is, right? RAM is the place where you have all the work going on. So would you afford to waste memory here?
No.
You cannot. Okay, because this is where the actual live magic happens. If you're running, if you're streaming, if you're downloading, if you're uploading, if you're listening to music, it's all happening here. This is a very precious area. So you have to be very careful when you choose the data type. Let me tell you why. Byte has a size of 1 byte, of course, as the name says. Short has 2 bytes.
2 bytes. 4.
4,
8.
8. Okay. Now let's see. Two byte is equal to how many bits?
16.
16.
Yes. 1 byte is equal to 8 bits. 2
16.
byte is equal to 16 bits. So think about this. One, 2, 3, 4, 5, 6, 7, 8, 9, 16. Okay, 16 bits. Now think about this line. If I have to store the value 1, what will you set it here? What will be the value?
0.
Think about these lines.
Oh, 1. Yeah. All zeros and then 1.
Okay. So you set
1.
1 here and
0.
0, 0, 0, 0.
so don't you feel for storing such a small number, we are wasting a lot of memory,
Mm-hmm.
Yes.
right? This doesn't really make sense. Choosing short to store a value 1 is really a huge waste of memory at the time when this is the most precious thing. If you cannot afford to waste memory, why are you using this? Okay, now let me give you an example. You're writing a software for calendar, okay, where you have to store things like month, day, month, year. Now, what is the maximum value you could ever have in day?
32.
360.
32? Did you invent a new calendar or something?
3. No. Days. 363. Or
360.
360.
So 31 is the max. And what is the maximum number of bytes to store?
128.
128. Okay, byte can allow you up to 128. So is byte a good choice to declare a day? Because you will never need any number greater than 31, isn't it?
Yeah.
Yes.
And byte can allow you to store up to 128.
Yes.
Okay, so the least you can do is a byte data type.
Right.
Okay, for storing numbers, the least you can get is byte. The maximum you get is long. Okay, now we can store this information, the day of the month, by choosing sensibly byte. Now if I choose integer, it will have 4 bytes. 4 byte is equal to 32 bits. That is a huge waste of memory. Okay, so now we are being more careful. So when you write a program, you'd rather choose the right size when you're writing the program. All of them will do the job. Okay, you can declare the variable as long. There is no error in that. No one is going to stop you from declaring long. But if you could do the job by just 1 byte, why would you waste it using a 8-byte data type? Okay, so byte is the right choice. How about month?
12.
12 is the maximum number. Can byte store the value 12?
Yeah.
Yes.
How about year?
Yes.
Okay, so the number, the limit is you can store up to any value of 128. Short allows you anywhere up to 32,000. Int allows you anywhere up to 2 billion. And this allows you to store trillions. Okay, that's the limit. You can store any value up to 2 billion and trillions. Okay, now 32,000, right? Fine. 33,000, error. Okay, same goes to integer. 2 billion, 3 billion, error. $10 billion, no problem. So you see, we have all of them: byte, short, int, long. All this type allows you to store numbers. What changes is how many numbers you can store and how much memory it needs in your RAM. in your heap space. Okay, how much memory you need to store the variable a's value is what defines this byte short int long. Okay, now coming to here, what would be the most sensible data type? Is byte okay?
No.
No. How about short?
Yes.
Yes.
Yes. Okay, I'm pretty sure 30,000 years from now Java programming language would not be around. Okay, so there is a safe bet that we can use short. Okay, this program will be good enough for the next 30,000 years if you declare as short. Int would be a waste of memory. We will never, I don't know if we will be around for the next 2 billion years. So int is just a waste of memory. So short would be a more sensible choice. With that in mind, what would you choose for account number?
Byte.
Now you do have account numbers, right? Usually how many digits long are they?
9.
9
digits.
So
Yes.
9 digit is about hundreds of million. Int is good. What if, like credit card, you have 16 digit number?
Yeah.
If your bank account, if your bank company has a 16 digit account number, 16, what would you choose the data type as?
Long. Long
Long.
should be
Long.
good.
Yes, long. Okay, so remember 2 billion. Do you know how many digits are in billion? 10.
I think.
Okay, there are 10 digits in a billion number. Okay, so you cannot have int if your account number is more than 10 numbers, 10 digits. Okay, you need to go with long. Okay, how about telephone number?
9 digit. 13 digits, sorry.
So remember,
Int.
can I do int?
Yes.
Yes.
Yeah.
Now what if your number starts from this is a 10 digit number, isn't it?
Yeah.
Yes.
So what this number starts with? 3. It's like 3 billion plus. And what is the limit?
2 billion.
2 billion. So any phone number that starts with 1 or 2 is fine. If a phone number starts with 3, you exceed the range of integer 2 billion. So is int the right choice?
No.
Not in
No.
case.
Long.
It's long.
Long is better. Okay, so do you see what exactly choice you have when you're declaring a variable? Okay, so here is what you need to remember. You already know how to write a program. When it comes to attributes, this line is what we call declare variable. Now what are we declaring here? We are declaring what's the name of this attribute. Yes, we are declaring what's the name of this attribute. We will call it money. We'll call it name. And what's the other thing we declared?
Account number.
The type.
The type. Okay, what type is this attribute? Is this money storing a number, a fraction number, alphabet, or just a yes or no? Okay, so declaring variable, this part of your program is called declaring variable. Okay, and what we declared here is the name and the type. Okay, without telling what type it is, how will you store information? Right? You have to be more specific. You have to be more clear when you're declaring variables. You have to tell what will we call it and what can it hold. Okay, two things. Name it and tell me what kind of information it can store. Two things. Okay, name it and tell me the type of that variable. And that's what this is. The type is integer and the name is account number. The type is float. The name is money. The type is string. The name is name. Okay, so declaring attributes has two parts: type and the attribute name. Is that clear?
Yes.
Yes.
Now you end this line with a semicolon. Okay, semicolon should be considered as an end of statement. Okay, end of statement. Now if you miss this, what's the problem here?
Error.
Oh, yeah, of course it's an error, but from a machine point of view, isn't it
It's going to read
confusing?
as a 1 number.
Right, isn't it confusing to machine that what are we trying to do here? Okay, what is the data type? What is the name? Is there any way to figure out what are we trying to say here?
No.
For humans, it might make sense. Okay, we read it and it might make sense. But for machines, for programs, you have to give clear instructions. Okay, where the first information begins, where it ends. Okay, if there is no separator, it cannot distinguish between both the information. Okay, so think about semicolon as the end of statement or a separator. Okay, it is separating between both the information, the account number information and the money. Okay, semicolon is end of statement, end of line. Okay, you have to give step-by-step instructions. Machines are dumb. Okay, they do not have the same intelligence as us, so we have to guide them through step by step. We have to tell them what I meant on this line, what I meant on next line. Semicolon tells you that this is where the first variable ends and this is where the second one begins. Okay, you can write everything in one line, that's fine. You are just saying that this is the first variable and this is the second variable. Okay, you have to give all the instructions to that. Okay, all right. Now these are all pretty straightforward information. Okay, these are all pretty straightforward information. Now think about, let's go back to one thing. Everything in Java is an object. Okay, everything. Java, as you know, is an object-oriented program, right? And every object has what?
Class.
Every object has
Class.
attributes and methods. Okay, in Java, every single program is an object, and every object usually has multiple attributes and multiple activity. Okay, now look at this for a moment. Does the number 30 has any activity?
No.
No.
No. Is there any sub information? Is it possible to have any sub information
No.
like we have here? So this is clearly against object oriented principle. This is what we call primitive data type. Okay, primitive data type are old ways of supporting information. Okay, in old days we used to store information like this, as an alphabet, as a number, as a fraction number, or yes or no. Okay, primitive data types are not objects. They do not follow the same principles of object-oriented program. Object-oriented program, anywhere you go, it has two parts. Okay, anything we discussed, this is a program. It has variables and methods. Variables, methods, variables, methods. Everything has variables and method, but these kind of information are something that do not fall in the usual object-oriented principles. Okay, all they have is a value, a literal value. Okay, so here is what you need to know. In your program, anytime you come across these things in the data type line, okay, in the data type line, if you see a highlighted word, it's a primitive data type. Okay, look at this. Now, which ones are objects and which one is a primitive data type? Highlighted.
Integer.
Int, float,
Primitive.
long, primitive data.
Highlighted ones are primitive.
Primitive.
Okay, int, float, long, char.
Boolean.
Primitive. Okay, how about string?
Yes.
It's
a
a
class.
variable.
Is string a primitive or an object?
Object.
Object.
An object. Okay, all these are supposed to store information. Okay, but there are two categories: primitive versus an object. Okay, so let's see when you will deal with objects rather than primitive data type. Okay, okay, a bank has a customer, an account, and name. Now tell me one thing. Your information can either fall in a simple category or a complex category. Okay, simple or complex. Now, when I say complex, what it means is it has sub-information. Okay, it has sub-information. Take customer for that matter. Now, customer, let's do this. Zip code. Is it just a plain simple 5-digit number?
Mm-hmm.
Yes.
Okay, do you feel this can have sub-information?
No.
Yeah, they have.
They have.
Let's consider for now it is a simple straightforward 5-digit number. How about phone number? A simple information. Name? Simple. Okay. Coming to customer, what data type suits customer?
String or character?
String.
String.
So,
Now, can you fit in the entire customer's information in one string?
No.
Oh,
Isn't this information complex?
Yes.
You have
yes.
first name, last name, you have email ID, phone number, address, city, state, zip code. So is this a complex information or a simple information?
Complex.
Complex. Coming to account, you have account type, you have account number. There are sub information, isn't it?
Mm-hmm.
Okay. Now, which one are simple information which can be defined as primitive, and which one are complex?
Teacher students are complex. School contact is simple.
This is simple data. Okay. So when you are designing softwares, you have to categorize in two things. Either they are simple information or they are complex. Complex refers to if there is sub information in that. Okay. If you say student, we have student's name, address, the class, okay, or the grade they belong to, okay, how much they scored. There are a lot of information inside school student. If you say teacher, teacher has name, address, salary, contact number, what subject they teach.
teacher.
Okay, it's a complex information. Okay, simple information can be represented as primitive or string. Okay, you can use primitive or string to define simple information. Okay, like a int, long, string. Okay, choose string object or any of the primitive data type to define simple data structure. If you have complex data structure, let's see what we can do with that. Okay, all right, so let's start the variables, designing variable process. Okay, you have school, and then you have teacher, student, and name, contact. Okay, so is this complex or simple?
Complex.
This one?
Complex.
Complex.
Yes.
Simple.
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 Now, if you have simple,
Simple.
remember you have choice like. Okay, let me write down all the categories here. Numbers, fractions, yes or no types, and character, single character, or group of character. These are your choices. Okay, if it is a simple. If it is a number, you have choice like byte, short, int, and long. Okay, if you have fractions, you have float or double. If you have yes or no type, you can use boolean. Character, char. Group of character, string. Okay, now here is the thing. Just like you saw how what limitations we have in each of these data type, right? Only 128 number, 32,000, 2 billion, and trillions, right? For storing fraction numbers, you can use float or double. The difference is how much precision you want. Okay, so if you want to store a number like this, 99.99, you can go with float. If you want a precision like this, I want maybe up to 10 fraction point, right? Up to 10 fraction point. You cannot choose float, you go with double. That's the only difference. How much accuracy you want on the fraction front is what the basis of choosing float or double. So imagine if you are writing a software for some science, some experiments and all that, atoms, molecules, astronomy, whatever, right? In those cases, these fraction numbers are very critical. So you cannot afford to have less fraction accuracy. So at that time, you can see some numbers which might have like up to 10 digit or 20 digit fraction point. So if you want to store a number, a fraction number like this, you go with double. But if you're storing something like a price, product price can only go up to 2-digit fraction, right? Cents. So in that case, which one is the right choice?
Float.
Float. Okay, remember float takes about 4 bytes and double takes about 8 bytes. Okay, so that's why you get more accuracy on this side, how much fraction numbers you can choose. Okay, all right, so this is your choice to store simple data. If you want to store simple data, these are your choices. To store a name, which one of these suits?
String.
And why string? Why not character?
Because it is a group of characters. You can use
Yes.
like first name, last name. So,
Name is made of group of characters. University of Phoenix. It's a group of characters, not just one character, but group of characters. If it is group of character, you choose string. All right, contact. Which one of these categories does it belong? Contact,
long.
let's say it's a phone number.
No. Short.
Contact phone number, short would be 32,000, right?
Int.
Using which is 4 bytes.
Long.
Long.
Long is 8 trillion. Okay, yeah.
Right. So now that we have taken care of simple information, simple attribute, let's deal with complex. Okay, remember we are dealing with attribute. School has teacher, school has student, school has name, school has contact. Okay, these are all attributes of the software school. Okay, so since teacher is a complex thing, what you do is you create a new class, another class. And call that teacher info. Okay, if it is a complex, you create another class called teacher info. Now, teacher info, let's say it has name, salary, subject they teach, and address. Okay, these are the information in teacher info. So, again, the same process. Which one are simple? Which one is complex?
Name is simple.
Simple.
Salary is simple.
So for name, what data type would you choose?
String.
Salary.
Int. Depends if she's
String. String.
no string
Address.
is complex.
Address is complex. Very good. So what do we do next?
Make another class.
To break it down.
Program. You create another program like this. Street, city, state, zip. Street.
String.
City.
String.
State.
Int. Oh no, sorry, string. Or
Zip.
Int.
int.
Is there any more complex information pending here?
No.
No.
Nothing. Okay, so now you trace your steps back. So the process is to go more and more level deeper until you hit a moment when nothing can be broken down further. Okay, think about this, like when you're building a house, do you immediately start with one room or one brick at a time?
One break at a time.
The same concept applies here. You start at the very ground level, okay, and then everything comes together. So think about this like one brick in your school software. You join enough brick and you got one module address. You got one room. You join this and you got a section of your school, and put all together, you get your entire software ready. Okay, so now that this is over, let's go back. We came from teacher info to address, right? What do I write here?
You're calling a function from address info.
You say address
Okay.
info. Okay, because this is a complex information. If you need more, sorry.
I have one question. As you said, like city has like exact name of city. We have a street, huh? We have got some like house number and then the street address. This is the mix up of integer and string. What to do with that?
Sure. If you want to break it down further, what do you do? If you feel this is complex, what do you do?
We can bring like house number to the integer and the street exact street name to the.
No. Wait for it. My question is, if you come across a complex information, what is the next step?
We go to make
Another class.
Another program.
Another class. That's what you do. Okay, don't jump. Think carefully. You say street info. You want to break it down further. Do it here. House number. Street name.
Street address.
Do you need anything else?
That's all.
Apartment number. Or
Now, what is house number? Is it complex or simple?
Integer. Simple.
What is a street name?
Simple. String.
Now that you define complex information here, you have to mention here. For attribute street, it is a complex. So we have another class created for that. So you have to write that name here. And tell that for street info, for street, look in another class called street info. Okay?
Okay.
We did the same thing here. Now, what do I write here?
Teacher info.
Yes. Student, complex. Create a class.
Student info.
Okay, so let's say student has name, grade, age, and address.
ID number.
Is name complex or simple?
Simple.
Simple.
If simple, which one do we need? Byte, float, boolean, char, string?
String.
String.
How about grade?
It's a character.
Grade is?
Character.
Number. No.
Integer.
Let's assume it's a number.
but
Oh, grade A, B, C. Oh, okay, you want to put a number. Yeah. Then it's an integer.
That's where you're wrong. See, people are very used to that term integer over and over.
Float.
Need a float. Sorry, yeah, it's point. Yeah, float.
No.
No, wrong.
It's a byte. Grade 5.5.
it's a byte.
Is there a school level? No. What I'm
No,
keep,
there's 99.9.
It's a group.
No. Grade as in school, 5th grade, 6th grade, 7th grade.
It's a group.
Oh,
That's a string.
Okay, 5th grade, 5th, 6th, 7th, these are the grades of the school. Okay. Yes, it is a number, but is int the right choice?
No.
So what do you use?
String.
It's a number.
Byte. What
You need
byte?
byte. Okay, do you have in any school, do you see like 128 grade or something? You'll have 1 to 10, right?
Yeah. Yeah.
The maximum number of grade will be 1 to 10 or 1 to 12.
Mm-hmm.
That's all. So why do you need int? So people are so used to this int. Anytime they think about a number, they go with int. You have to think through Which is the right choice? Byte short, can we use one of them? Okay. All right, how about age?
Byte.
Very good. But as you know, the longest person who has lived is like 150, you know? Well, but we don't expect anyone 128
Byte.
right? So yes, that makes sense. Byte is good. How about address?
It's complex.
Address info. Mhm.
This is complex, but here is the question. Do I create a new class?
Yes.
Yes.
Or can I use the same one?
Yes.
Yes.
Use
Yeah,
the same
yeah.
one.
Yes.
So here is the question you ask.
It's
And
irritate.
teacher's address and student address, does that really change? Address is just address, isn't it?
True.
Every
Yes, sir.
address has street, city, state, zip code. Does it change for teacher or student?
No.
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 It
Why
doesn't
do
matter.
you need another class? Address info. Use the same class name here. And this is how you write a program, a software. You might be wondering, right? Amazon, Facebook, whatever Java projects they have they written the entire Amazon or Facebook code in this one file? Is that what you feel?
No.
No.
That's
No.
simple.
As Bank of America or Chase Bank wrote their entire website in one file?
No.
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 There are
It's
hundreds
gonna
and
be
hundreds
called.
of programs that run
Mhm.
your Java-based projects. The question
Mhm.
is, why do they need hundreds of programs? Answer is, this is the process that will break down your system into smaller groups, which is manageable. Okay? This is now manageable. If you write entire Facebook or Amazon in one Java program, there will be millions of lines of code in one file. Now, can you imagine the headache to fix any problem on the Amazon website if you had to read through a million lines? Now think about this. Even school, okay, University of Phoenix, they all have their website. If they write their entire website in one Java program, it would be hundreds of thousands of lines of code. Okay. If I ask you to look into the Phoenix website, there is a problem. If somebody tries to enter the house number, their registration fails. Where would you look at in this example? If I tell you there is a problem in the house number input text box in the website, where would you look at?
Street info.
Only one
Street
class.
info
It has like maybe 50 or 60 lines of code. Isn't that better rather than looking in one class which has hundreds of thousands of lines? So
Easy.
isn't it manageable? The reason we have all these programs in separate is, one, it is much more precise, much more clear. And second, it is more manageable. Tomorrow, if I tell you to look at the salary section of teachers, you don't have to look at one class which has hundreds of thousands of lines. You can go to only one program which is responsible for teacher's salary and look at what is the problem in this class. It is more manageable. If you take your car to some repair shop and you tell them that my tail light is not working, do they entirely reassemble your entire car, or they just look at the piece where the tail light is?
Just the piece.
Just the
Just look at the piece.
Right? Every component of a car can come apart. Your tires, your tail light, your engines, everything can come apart and be fixed individually. So why should your software programming be any different? It's the same concept. It's a common sense. Okay, what is true in the real world, it applies here as well. It is common sense. So when you start writing a program, you break it down into smaller manageable components. Smaller manageable components. So you can manage each of them individually. If you want to make some changes, it is easier because it is independent. If you want to fix something, if you want to find a problem, easier because everything is managed independently. Okay. So this is the word you need to think about, modularized. Everything is a small module or component. Everything is a small component. So now it's like divide and conquer, isn't it?
Yeah.
You take a big software like a Phoenix website, then you break it down into smaller components. And now you start with the smallest one. Focus only on one thing at a time. Won't it be overwhelming when I ask you to write a website like Facebook? Where do you begin? There are so many things. Customer profile, post, so many things are there on the Facebook website. Where do I begin? Now sit down, relax, put a simple graph like this. Facebook, what Facebook has. It has customers, it has post. How do I break down customer? Here. Any complex information, break down further. Now, anything you want to manage, you can start with one thing at a time. Focus on one thing at a time. Divide and conquer. Modularized. You should never write one program for the entire software. Nobody does that. It would be crazy. You have to break it down into smaller and smaller components and work on them individually. Okay? So let's write our software for this. All right, I have school. What is the next class I need? Teacher info. Address info. Street info. Student info. All right, so how many classes we have? 1, 2, 3, 4, 5. Okay, so we have 1, 2, 3, 4, and 5. Okay, we have 5 classes. All right, so I created 5 classes. Let's start with the smallest one. There are 2 attributes, house number, street name. Copy and paste. So this is where you declare the variables, right? What does it end with? What is a special character?
Semicolon.
Semicolon.
Yes. All right, so street info is ready along with its variables. Next one is this, address info. You're good? Primitive, simple, object simple, complex, street info. Teacher info, okay, I spelled it wrong, address info, student info, okay. So remember, you can start with your spreadsheet or a piece of paper and then come up with a structure like this. And finally, school test. Okay, you get the idea, right? Okay, we have all the classes we need and all the variables, and now you see how they all connect together. Okay, so this is the overview. School has teacher, and teacher has address, address has street. Okay, they all belong to the same group, which is school test. They all are part of the school test, but anytime it becomes difficult to manage them, any information you feel difficult to manage, that is complex, you create another class for it and store the information there. Okay, so this is how you declare all the variables. So what I want you guys to do is, whatever examples you chose, supermarket, okay, or bicycle, whatever information example you chose, I want you to practice similar thing. Start with simple things. Okay, you took supermarket and you wrote customers, food, and all that, right? Now see, customer, is it complex or simple? If it is complex, create another class called customer and write down all the information about customer. Any information here sounds complex, create another thing. You keep doing that until you hit one level where nothing can be broken down further. Everything is simple. Everything is simple. You need not dig it down deeper. Until then, you keep digging. Okay, so once you have this representation of your entire software, what are the different programs, how they are connected to each other? Okay, what are the different programs and how they are connected to each other? This is what the overview tells you. Once you do that, you start writing programs. Okay, class for school, class for teacher info, class for student info. Just create all those classes and you can copy paste these lines. Okay, that should be simple enough. All right, so there are two kind of data types. Okay, one which is highlighted and one which is not. The ones which are highlighted, they are all primitive data type. The ones which are not highlighted, they are object data type. Primitive and object. Primitive and object. Two kind of data types. The primitive data types can be numbers, fraction numbers, yes or no, true or false kind of information, Boolean, or just one character. That's primitive data type. An object is usually pointing to another class. That's what object means. If it is not highlighted, you will see another class like that. Address info is not highlighted. There is a class called address info, isn't it? Teacher info is not highlighted. Is there a class called teacher info?
Yeah.
Okay, the ones that don't highlight data type, they actually are another classes in your project. The ones that highlight, they are primitive data type. They don't exist as public class. There is no program called public class int. So that's why they are highlighting. So any information that you come across will fall in two categories. One is primitive, another you will find as a class. Okay, do you see any discrepancy here? Do you have any questions from the objects? Teacher info, isn't there a teacher info class here?
Yeah.
Student info,
Yeah.
did you write a class called string?
No.
No. So why is this highlighting if you didn't write a class called string?
Because it's an object, non-primitive.
Okay. So this particular class is what we call inbuilt objects. This is inbuilt, and this is user or developer provided. Teacher info is developer provided. I wrote this, isn't it? Student info, it is developer provided. String is inbuilt. Inbuilt meaning this came to you as part of Java installation. Okay. Now you did install JDK, right? Where did you install that? Right. Now let's look at this. Do you see a program called string?
Yeah.
Yes.
You didn't write this, but didn't you get this file as part of JDK installation?
Oh. Mm-hmm.
So that's why they are called inbuilt. There are some programs that you write, and there are some programs that will be given to you when you install JDK. When you install Java, they gave you these programs. So you can use either these classes or you can use one of your own classes. And that's the reason you have both the options. Okay. The primitive data type is simple, but the object data type can be either developer provided, teacher info, student info, or it can be inbuilt, string. String is the inbuilt program. Okay, this is developer provided program. This is inbuilt program. Inbuilt programs are those which will be available to you when you install Java. When you install Java, these were the programs you got as part of installation, freebies. Okay, these are given to you to make your life easier. So you don't have to write a program of your own to manage the group of characters. Okay, so bullet points. Variable declaration. What does variable declaration include?
Data type
type,
and name.
name, semicolon. Okay. Example, int number, semicolon. This is an example. Okay. Now, what are the options for type?
Byte, integer, long, short,
And simple
long, simple.
or complex. Okay. Simple is usually primitive, such as int, long, short, boolean, float, and so on. Or it can be string. Okay, so rather than like this, type I can say primitive or object. Okay. Object can be inbuilt like this. Okay. So in case of variables, first thing you need to know is declaration. How do you declare them? First comes type, and then comes the name, and finally a semicolon. So type is integer, and let's say the name I give for this variable is age. Okay. Type is integer, name is age, and semicolon. This is how we declare the variable. Okay. Now, digging down deeper about the type can be either primitive or object. Primitive are those which are either numbers, fraction numbers, yes or no, and finally character. Okay, these are primitive. So information could be like this. Objects can be either inbuilt classes that was given to you when you install Java, or it can be developer provided classes, the ones we created ourselves: street info, student info, address info, teacher info. Okay, it can be either one of the programs that we wrote, or it can be one of the programs that you got when you installed Java. Okay, those are your two choices. Okay, when choosing the right data type, this is a simple trick. Decide if it is simple or complex. If it is simple, then you can choose any of the primitive types or string. If it is complex, you create a new class and define all the details there. And this goes on every time you find something complex info or complex system, you take it down further and write it in another class. This is a simple task you can do. Okay, so remember these points and do this exercise and create your system, create your program, create your software. Whatever examples you chose, you can take that and come up with an architecture like this, come up with a design like this. Do this in a piece of paper, doesn't matter. Okay, so write it down further and make it simple. Remember, divide and conquer. You have to modularize. You cannot do a huge task in one go. You break it down into smaller pieces and you achieve that one day at a time. Okay, you don't get the whole thing done immediately. Divide and conquer. Okay, you have to break down your system into smaller, manageable modules or components. You have to break it down into smaller, manageable components and then take care of them one at a time. Okay?